moved on to name it, context, kubectl, anything else? API objects, right. And the context will have three important things: CUN, cluster, user, namespace. All right. Then we've seen something else. We've seen replica sets, daemonsets, stateful application, very good. Persistence volume, persistence volume climb, storage class. Right. Fantastic. All right. We're going to add a couple of things to here. We're going to add a role binding, cluster binding, this is all RBAC, role-based access control, very popularly known as RBAC. All right. And then we have config map and a related word, secret. All right. Then we will talk about Helm. When somebody says, what do you know about Kubernetes? All these things should come to you in the same order. They are logically ordered. If you can logically put them in place, you will be able to explain it easily. They are all connected. So we're talking role binding, cluster binding, config map, secret, Helm, HELM. All right. Let's see what is this. What are these three things? Role binding, cluster binding. Let's see what is a role. We've already talked about roles in AWS. And we also said the users, groups, roles, policies. They are always same in any technology. The concepts. This combination is always same. It does not change. We know what a user is. Well, like any what we call principal or ID that logs into your system. All right. A group of users is usually groups. What is a role? A set of things that the user can do. The authorization. A policy is a list of roles. That's what we talked about. Very simple. Now role, look at this. A role basically tells what you can do once you logged in to the system. So users are usually related to authentication. This is a very important distinction. Always remember this. Authentication, authorization. These two things you will always come across. Authentication is whether you are allowed to log in or not. Once you are allowed, whether you are allowed to do something or not, that's authorization. So every user has to be authenticated. After the authentication, you have certain authorizations. The authorization is usually, like you asked, who checks that authorization? So there is usually an authorization module. So every time you click on anything, the authorization module checks whether you have permission to do it or not. All right. Now that is usually a role. In Kubernetes also roles. Kubernetes also implements role-based access control, RBAC. Role-based access control. So we are simply saying Kubernetes uses roles to allow or deny certain thing to all the users. RBAC, role-based access control. All right. Now let's say if you are a regular user and you are trying to log in, take your example of Gmail. When we log into Gmail, you give your username password, right? That's usually a user. Now, as opposed to regular user, Gmail itself will have certain other softwares which will clean up this Gmail. Let's say your spam, all right? So when emails come into your inbox, they are segregated. What are important, promotional mails, ads, then spam. Now all this thing is being done by somebody, right? Let's say this is a Gmail software and this is your inbox. This is the Gmail software. Just like your inbox, lot of inbox are there, billions of inboxes. Everybody has an inbox. Now let's say there is a software which is again part of bigger Gmail, which keeps checking all the inboxes and segregating your emails. Now this software also need to log into your inbox. Yes, right? Whether it's a regular user or any other software, everybody has to log into any software. It's not like just because this is a Gmail software, it will be allowed to log in. The same way, you might have another, let's say, Drive like kind of software. This also need to access this one sometimes. So we have two types of accesses coming into any software. Regular users logging in, where you have an interface, you will be given a username and password, then you log in. Then there are services that will log in. Here in this case, it's called a service. It's a software program. So you have two types of usually users. One is regular users who will actually log in, and then service. So we have user accounts and service account. Now you will come across this word service account in every cloud. When you are creating a service account, it means you are allowing one program to access another program by using a service account. So here what you do is, you give this service account to this software and you tell this software, use the service account to connect to another software. So you will have regular user accounts and service accounts always. And the service accounts usually have, just like username password here, these have ID and key, usually called key ID, key value, sorry. You have ID and value, just like username, password. ID is usually any ID that you give. Let's say you give some ID like Gmail account 1. Key value is usually a very big number you will come across. Then you logged in using AWS when you created your first user. You got a key ID and a value. That's what you actually download. All right? The same way. So you will come across this word again and again. Now come back here. So what we have is a role which can be assigned to a user account or a service account, right? Whatever may be the account. Now, what this account can do depends on the role that is allocated. Now, the question is, how do we allocate that role? We have to tell this service account, let's say service account 1 has role 1. We have to say that somewhere, right? Now, this saying is usually called binding. So, role binding, what it means is assigning a role to an account. That's your role binding. Assigning a role to account. Now, the account can be a regular user account or it can be a service account, anything. So we know what a role is, and then we bind the role to an account. So binding is assigning. All right. So we have a role and role binding. Now, when you bind a role, you can bind it for the whole cluster. For example, we have our cluster, master, worker 1, worker 2, right? Then you have HCD, Kube API, scheduler, controller, CRI, kubelet, kubeproxy, right? Now you have namespace, logical division of this cluster, all right? Now let's say you have a namespace 1 or cube system. This is one namespace available by default in a Kubernetes cluster. Now, when you are assigning a role or binding a role for a specific namespace, it is simply called a role binding. For example, you create a user, let's say here, anything happens through Kube API, right? So let's say you create kubectl create kubectl user create, you say something, all right? Let's say account 1. Now, when you create an account, after that you bind a role to this account. When you are binding the role, you can bind it at namespace level or all namespaces in the cluster. If you bind it at a namespace level, it's simply called role bind. If you bind it using cluster binding, you are binding it to all namespaces. So role binding is again assigning a role but namespace level. Cluster binding, cluster level. Now ideally it should have been called namespace role binding, cluster role binding. That's ideally the name should have been, isn't it? But here we are not calling it namespace role binding, we are simply calling it role binding. Now this whole role binding is again put into a YAML file. I'll just show you one such YAML file. See this? This is a YAML file for a simple role. You're defining a role. You see the kind is role. We have again the four these things: API version, kind, metadata, and you should have specs in it. It's partial file. All right. So here if you see role, now the role has rules, what this person can do. A role is just a list of things that an account can do, right? Now, once you have a role, you're going to bind that role to an account. It could be a user account or a service account. This one. This is how you bind it. You just say cluster role. It's a cluster level. Role binding. This is namespace level. Right, we will see this YAML files. What? ఎందుకు రావట్లేదు ముందు చెక్ చేయలేదా మరి అది పని చేస్తున్నారు alright so we have roles, role bindings, cluster bindings. Let's come back here. Any questions so far? Let's look at this combination next. Config maps, secrets. These are usually a pair kind of thing. They usually come together. Any virtual machine, when you see, has a lot of variables when you log in, right? You have variables like $user, $kubeconfig, $shell, which shell you are in, right? $path, you have class path. Any Unix system usually has these variables. Just like these variables, Kubernetes also has certain variables, or a Kubernetes application usually has certain variables associated with it, right? Now, all such variables are usually stored in a config map. So, a config map is environment variables. All config maps are environment variables. Put Raja. Mali try చేయి Right. Now, just like config map, you will also have usernames, password, right? Or your key value pairs, the key ID and key value. Now, anything that is sensitive is usually a secret. So, config maps are environment variables. Secrets are sensitive information, or username, passwords. So let's write it down here. Config map secret. The secrets are sensitive info. It need not be username, passwords. It can be anything that you consider it's sensitive. Usually username, passwords. username, passwords, key value, key IDs, key values, that kind of thing. Now, when you are dealing with secrets, you will come across a word base 64. We will see that in our workshop also. Base 64 encoding, it's called. Now, there is an important distinction here. Encrypting is another word versus encoding. What is encrypting? When you say you have encrypted something, some piece of information, what does that mean? Hiding with something else. So you are changing the original look or nature of the original thing so that to anybody who reads such information or looks at it does not realize what it is. Just misguiding something. Right. Now to do an encryption, we have a lot of techniques. A very simple technique that we can use is you take the alphabets A, B, C, D and you just move it. We all learn these things, analytical questions, all that things. All right. So encryption is usually changing data. Like for example, let's say you take a word. When you encrypt it, it might become anything, depending on how you are encrypting. All right. It can be anything. Now, usually you have lots of methods of encryption. All right. Now, as opposed to encrypt, now the purpose of encrypting is to hide the original information. Now, as opposed to encryption, there is a word encoding. Encoding is instead of putting the same word, right, in plain, you just give a big number to it, or you store it like just like a number. Now, to do this encoding, there is a command base 64. You'll see that in all Unix systems. So you give base 64 ABC, it gives a big number. Let's say it gives XYZ ABC. Now you can pass the same reverse number to base 64. All right, and it will give you back this thing. Now the reason why we use or encode some information is sometimes special characters that you want to put in are not usually placeable in a text, ASCII, all that kind of stuff. So when you don't want the original number, when the file moves from one system to another system, the most notable difference you will see is when you open something in Windows versus you take the file and you put it onto a Unix system, the lines, new line at the end, all right, they will not work in Unix. You will have this problem. Usually, a developer usually creates a file in a Windows system. They give it to you, you put it onto a Unix system, all right, it doesn't work. The reason is the end of lines are different in each system. That is called ASCII character set. ASCII character sets, if they are different on different operating systems, what happens is on one system, you might see one word. If you take to another operating system, especially this problem you will see across operating systems. One operating system will have one ASCII character, means the end of line is denoted in one way. And if you take the same file to another operating system, the end of the line is denoted in a separate way. Now, if you send some information like this across the operating systems, you might see ABC on one system and something else on another system. So you want to avoid that. Now, to avoid that, what you normally do is you encode the original information, all right? Send that original information to a remote server. Then again, decode it over there. The same command is used in both cases. Alright, so you will see that in our workshop. So this is a common word you will come across because many of the YAML files you will see encoded information. Now do not confuse encoding with encrypting. Encoding, the purpose of encoding is not to hide the original information. If you want to hide something, you should encrypt it. Now the encryption is usually done in a secret because that's what you are trying to hide there. So config map here, I'm going to add a couple of words here. Yeah, encoding, encrypt versus encode. Let's see the next item. Any questions in this? What are config maps? Environment variables and secrets, sensitive information, username, passwords, key ID values, that kind of stuff. Encryption versus encoding. Encryption is to hide the information. Encoding is to transfer the information across the platforms usually. You're not trying to hide when you're trying to encode. And the command to encode is base 64. Let's look at the last component, Helm. HELM. Helm is related to deployments. What is a deployment? We already know. Creating your application or deploying a group of pods or creating those group of pods. Now, when you deploy, you are basically deploying pods, means containers, isn't it? So if you see here, again, master, HCDA, API, scheduler, controller, worker 1, worker 2. Now let's say there is a namespace and you have a couple of pods in it. Each pod has a container. Alright. Now this group of pods, you're calling it a deployment. Obviously, this deployment has to be stored somewhere. Let's say you have the YAML file deploy.yaml. Even for deployment, everything in Kubernetes is deployment or a YAML file. We have a word for this one, declarative. Declarative approach. You tell what you want in the YAML file or you declare what you want in a YAML file. Very simple. So you have 4 items here, API version. What's next? Kind, metadata, specs, spec. The same thing. Now, in case of a deployment, your kind is going to be deployment. All right. Now, let's look at developing such YAML file. Now, if you are deploying a big application, for example, let's say no, the ICICI Bank application itself, you have several modules in ICICI, or on that day we were talking about Amazon. You have a big list of containers that will have individual software components in it. What are the various lists we have given? Can we quickly recollect? Amazon, you have user interface where the inventory is shown. Then you have, which one? Okay, we have cart, then we have payments, then we have delivery tracking, then we have returns, then we have SMS, email, all that channels, everything. Right. Now each one of them, assume, is put into a container and being deployed as a pod through a deployment. Now obviously, when you are deploying one version, let's say V1, you will have at least some of these components, if not all, some of these components, because each one of them is getting developed independently, and whenever there is a development, they usually push it to the whole thing. Now, when they push it, obviously, it has to go through the whole SDLC process. Everything has to go through the SDLC process. You have dev, QA, UAT, SIT, system integration test, LT, then probably a pre-prod, and finally prod. This process does not change. Any software has to go through it. If you are using DevOps, you are simply implementing certain tools to make this process faster and automated. That's all you are doing. So even for a regular deployment, even for a Kubernetes deployment, it has to go through the same process. Now, when it is going through the same process, and when you have lot of such things, especially you have lot of YAML files. Let's say you have about 20, 30 YAML files. Just a rough number on any deployment. All right. Now, all the 20, 30 YAML files, let's say Kubernetes is installed everywhere. Everywhere you should have Kubernetes, right? If you have production in Kubernetes, all things have to be in Kubernetes. All right. Now, you have a version, let's say a bundle here of all these things. All right. You deploy it to QA. Then you deploy it to UAT, then you take it to LT, then you take it to pre-prod, then you take it to prod. Now, because these are containers, your deployment is always containers. So somewhere you have created a container image. All right. Earlier, if you see Jenkins, let's say this is your Jenkins. What we have seen, what is the artifact that we have built? A var file. When you ran a Jenkins job, you basically created a var file. Now, a var file is usually Java code. Now, let's take it to the next level. Let's say that application, you containerized this application. Means you're not taking a var file and deploying it to Tomcat anymore. Instead, here itself, we are putting the var file inside a container. So on Jenkins, you extended your Jenkins job. Next step, what we are doing is, we are doing a Docker build. In this build, you are putting a var file. Now, obviously, when you are putting a var file, you have to put it on top of a Tomcat server. So what your container has, or what your image is, you have a very small footprint of operating system. It's usually Alpine operating system. Just like Ubuntu or Windows, there is another operating system, very small footprint, Alpine. All right. On top of it, you will install Tomcat, what you want. On top of it, you will deploy your var file. This whole thing you're going to do using a Docker build. So instead of a var file, what you now have is a complete image. And once this image is ready, you will put it into a repo. What's the repository, you know? For images, Docker images? Docker Hub. For var file, you know Nexus. Nexus can also be used just to put these images. Nexus can do regular var files, or it can also store and list images. It's just a file for Nexus. It doesn't really matter what kind of file it is. All right. So what you have now is images and a list of files, isn't it? Files are these. All these files will refer to these images. When you are saying a deployment, you're essentially saying, give me 5 replicas of this specific container. And how does a container get created? Using an image, which means these files will always refer to the images. So you have two components for any deployment. One is a file and then an image associated with it. The container is like this. Let's call it image, an image like this. This is a Docker image. So what this file will do is, it will pull the image and launch the pods, right? So Helm, the one that we are talking here, will help you bundle these files and these images. If you have 20, 30 files together, it becomes really difficult to put these things together across your SDLC. You keep missing your files. So somewhere you need to make sure we are always getting the correct files. So the way you do is you bundle all these things, YAML files, and these YAML files usually refer to container images somewhere on the repository. It could be a public repository like Docker Hub. It could be a private repository that you can set up on your local network. All right, we have already set up that Docker registry on that day, right? That's a private registry. Now here, a list of YAML files bundled together is called a chart. So a chart is a bundle of YAML files. And usually they're about deployments. Now let's take a practical example. Let's say you are deploying a monitoring system to all the Kubernetes cluster. Now, if you are trying to monitor this, you obviously want to monitor all the nodes. You obviously want to monitor your HCD and your kube API, scheduler and everything, because these are also pods. You also want to monitor all the deployments running, right? Now, when you want to monitor these things, the software should have permissions to do that, which means it should have appropriate roles and role bindings, right? So you have to define all these things somewhere, right? So what you have is, for example, you have a file role.yaml, you have a file role binding.yaml, you have a file deployment.yaml, then you have a file pod.yaml. Yes, right? You have to define how a pod is. Then you will have services because that has to be exposed. So service.yaml. Then you will probably have ingress.yaml. These are a bundle of files that will come in any software. Now, when you want to deploy it, all these bundles, it need not be just deployment. Everything that the software needs for it to work is usually put into a YAML file, and this whole bundle, we will call it a chart. Now, when you are bundling files, it obviously looks like a directory. You're just opening a directory and you have a bunch of files. All right. Now, this chart is what your Helm is managing. Helm is the tool that will help you create the charts. So you have, let's take the master here. This is your HCD API. Scheduler proxy. Now again, anything has to connect to API. We already know that. kubectl is the command you already know. The next command is Helm. Now Helm can initialize a chart. It can create a chart. If it can create, it can delete a chart. It can upgrade a chart. It can roll back a chart. These are the 5 or 6 things that you will commonly do with Helm. Initialize, create, upgrade, rollback, delete. Now querying is usually before, if you want to upgrade something, you want to query it. All right. This is get. Remember these 6 commands. That's more than enough usually. Now a chart usually has a structure like this. Check. Let's say your chart name is my chart. You usually have these 3 files, and the first file is mandatory. So a chart.yaml basically tells what the chart is all about. In that, you have C caps, C-H-A-R-T YAML. C is not caps here, there, but it's actually capital letter. So what you have is a directory where this is a name of chart. Under that, you have a directory structure list. One file you will see is chart.yaml file. The other 2 common files you will see is values, again YAML file, requirements .yaml file. These are the 3 common files. The first one is mandatory. So when you say init, Helm init, you're essentially creating this structure in one go. You don't have to create manually. So it creates a template directory for you. So we're calling it a chart. Now once you have these files, then you have a directory here, templates. This whole bundle of YAML files is here under templates. So what you have now is under templates, you will have pod.yaml, deployment.yaml, service.yaml, role.yaml, anything that usually that software requires. Role binding.yaml, ingress.yaml, config map.yaml, a secret.yaml, anything. So all the files related to the chart are usually in here. Now this is the general structure of any chart. So what normally happens is you bundle this whole chart, all right? Now how do you bundle stuff normally? What format? In Unix, a tar. Perfect. So you basically tar this file, tar cvf mychart.tar, your directory mychart. So you have a tar file. So all charts are usually in tar files. Now when you have a tar, you untar it and you deploy. Now this whole chart, who creates this chart for us? Which team create, where do you get this tar file? A development team. Just like a Java application, a Kubernetes application is also developed by a development team. So they know how to create the charts. We also will do it sometimes, all right? So what you have is a chart. Now let's say how Helm will deploy using this chart. So let's say you have this chart as a bundle, all right, and you put it into a repository. What are the other repositories you already familiar with? Code repository. What is the code repo you know about? Git, correct, GitHub. Then you know about artifact repository, Nexus. Then you know about image repository, Docker Hub. Is Docker Hub same as Nexus? What's the difference? Can Nexus store images? Why not? What could be the problem? Any file it can store, shall I say? Yes, no? Why not? No. When you logged into Nexus, you would have seen over there, it can store anything. Nexus is a repository of artifacts, including Docker images. So it's not necessary to actually do only on Docker Hub or any private registry. You can use Nexus also to store your Docker images. So Nexus can work as a private registry. So you have a code repository where the raw code gets stored, and once you compile and build it, you store those artifacts into a artifact repository. Now the third repository that you are seeing is chart repository or Helm repositories. You're going to store Helm charts here. Helm charts are again tar files most of the times. Can Nexus work as a Helm repository? Yes, it can store pretty much anything. So you can use Nexus also as a Helm repository. So Nexus can store and manage Helm charts also. But a most popular Helm repository is Chart Museum. Just like Docker, popular registry is Docker Hub. Even though Nexus can do it, Docker Hub is what is popular. The same way, for Helm charts also, we can store it in Nexus, but the popular one is Chart Museum. We have a big list of public Docker images, right? On Docker Hub, we just do a Docker pull and pull that image to our local environment. The same way, a big list of public charts are also available. They are available on helm.sh. That's a website for public charts. All right. With Helm, and you will actually this also works as a repository. Now normally, so what happens is you download a chart, all right, and then you deploy it. Let's see a couple of other commands. Helm add a repo. That will be the URL of that repository. Helm list ls and Helm search for a chart keyword. So we have about 10 Helm commands. Let's see here. Helm init if you want to create a new chart. Helm search for public charts. All right. Then add a repo. Helm add a repo. All right. Then Helm create a release. This is what the name of the application. A release is called name of application. You can give anything you want. All right. Then Helm list everything in all namespaces -a. Usually, any of the commands are namespace specific. Now, if you want to run the command across all the namespaces, -a, just add it. I'll give you the list of Kubernetes commands, Helm commands, once we start the workshop. But these are the common things that you'll see. Then after create, Helm delete. Last one that will be. Then you get all the list, get a release, then you upgrade a release, upgrade release, then you roll back a release. There is no downgrade. Instead of downgrade, they said roll back. Yeah, those are the commands you have. We'll be doing all these things, and we have workshop. So how many commands you have? 3, 3, 6, 8 commands approximately. Now recently, the architecture of Helm has changed. Now, Helm has version 2 and version 3. The architecture of Helm was like this. You may come across the question on the architecture. Now this is master, and you have etcd and kube API, right? In Helm 2, you used to have a component called tiller, which gets installed here, just like your kubectl or kubectl. Anyway, it has a component called tiller. We're talking about 2. Now the tiller has all the admin privileges on Kubernetes cluster. Full admin this is. Now because it has full admin, the reason why it has full admin is because it's trying to deploy an application, right? That's what normally a Helm does. Right? Now to do the deployment efficiently, in version 2, they gave full admin privileges, or they attached a role with full admin to tiller component. But a lot of people have raised a security concern because Tiller has all the admin privileges. Now, anybody who has access to Tiller will get complete control over the Kubernetes cluster. Now, that is causing a problem with separation. Means a deployment team cannot be separated from administration team. Normally, what normally happens is in large environments, one team will completely focus on deployments. All that they do is your Helm things. Then there is another team which will do the setup of Kubernetes. Right now, that's what is happening. If you see, any companies that are running Kubernetes but they don't have resources, what they do is, for example, let's say there is Rackspace. Rackspace has a group of people, about 50, 100 people. All that they do is create Kubernetes clusters. And where they do it on the environments of the client. Now, once they create the clusters are given to development teams. Usually, these development teams are in Infosys, TCS, CTS, these guys. Now, the developers do not know how to create clusters. So, there is a team which works only on administrative activities. Then there is another team which has complete deployments kind of thing. So, the deployment team need not have full admin privileges. But if we give Tiller access to them, because we have to give Helm, right, to deployment. So what essentially we're doing, we're giving the whole admin rights on the cluster. So that's a security concern, and that concern is addressed in Helm 3. So what they have done is they have removed Tiller. So there is no Tiller component in Helm 3. You might come across the question. So the difference between Helm 2 and Helm 3 is a missing Tiller component. Now that is internal. We don't have to really worry about Tiller missing or Tiller not missing. Even when you're working on Helm 2, you don't really operate Tiller. Your commands are still same, right? So you have to make sure you're working on correct version. Helm version, that's the command to see the version of Helm. It is either 3 or it is 2, one of these two. Any questions here? Let me give a clear distinction here. So a Helm chart, so you have chart.yaml, then values, requirements, then templates. It can be called anything. You can call it charts also. Then you have YAML files, right? Now this whole bundle is in one repository. This bundle actually refers to all the container images, right? Those containers are also all in a different repository. Understand the distinction here. So when you're working with charts, you are basically visualizing two repositories. This is a chart repository where only the YAML files are there as a bundle. These YAML files, when you deploy to a Kubernetes cluster, they will pull the images from a image repository, Docker image repository. These are two different things. So what you will be doing is, usually you have a chart museum deployed where all the charts are running, and these charts are referring to Docker Hub for images. So when you deploy to a Kubernetes cluster, a chart museum is what the YAML file are taken from, and once the YAML file comes in, it goes to the Docker Hub again and pulls the Docker image it requires to deploy your pods. So make sure you understand the distinction between these two. Now once you have the clarity on this thing, you know what Helm is actually doing. Very simple, all right? That's all, Helm. Any questions? Sandhya? Arjun. Any questions on this? Can we finish that AWS thing today? It's going a little slow. Can we do that? Any questions in AWS from the activities that you've done? The problem with AWS is too much. It's too much. Even Kubernetes is too much. We are trying to cover too many things. Any questions from AWS? Yeah, go ahead. Any questions? No, okay. Okay then, so we'll start the workshop on AWS. Try to finish all the tasks today. I think we have finished 5. We still have 5 more. All right, try to finish those things. Are the instructions clear in that document? All right, you are able to follow the instructions and complete the task? Perfect. All right, so let's start that workshop. Thank you, guys. Sandhya, Saj. And the context will have the important thing.